So yesterday we talked about some basic properties. We're going to review them and write them kind of all in one little reference sheet here for you. So remember that a common logarithm, so if it's a common log, has a base 10, and it's just written as log x. You don't put the base on it, right? And then a natural logarithm with base e is written as ln of x. That is not an I, it is a lowercase l. Then we have some easy basic properties here. Log base b, meaning the base can be anything, of 1 will always be the same answer. Because if you think about if we rewrote it exponentially, b to this power equals 1, well, what power can you take anything to give you 1? 0. It's a 0, yeah. So 0. So if you take the log of 1, your answer is 0 every time. And then log base b of b, well, b to what power gives you b? 1. So if the base and the argument are the same, then your answer is just 1 every time. And if you forget that, you can always just rewrite it exponentially and figure it out. It's not that big of a deal. Okay, so log base 6 of 1, what would that have to be? Look back over here. 0. And log base 4 of 4 would have to be what? 1. See how easy that is? All right, so our product property, as a reminder, if we have the log of two things that are being multiplied, we can split it into two logs with that base that are being added. So this would be log base b of m plus log base b of n. And we can use that to expand and condense. So if we're going to condense these two, I'm adding them. They have the same base. So then I end up multiplying. So this would give me log base 3 of 24x. Right? Then if I need to expand using the product property, that would mean that I would need some multiplication in here, which I don't directly see, but I can factor, right? So that would equal the natural log of, I'm going to factor it into two binomials. I know this would be x, and the signs would have to be opposite. So what are my numbers? One and -2, positive 1 and -2, right? So now I have the natural log of two things that are being multiplied, and I can say that's equal to the natural log of x plus 1 plus the natural log of x minus 2. Okay. All right, so our quotient property, we can change division and split it into subtraction. So this would be log base b of m minus log base b of n. And I can use that to condense and expand. So here subtracting, that would be 1 log where they're being divided, 80 over 16. Then I would need to reduce. How many times does 60 go into 80? How many times does 16 go into 80? 5. So this would just be the log of 5. Then I can use it to expand. It's being divided, so I can split it into subtraction and get log of base 2 of x minus log base 2 of 5. Power property. Remember, if you have an exponent, it just comes out in front here. So log base b of m to the nth would become n times log base b of m. So to condense this 3 comes up here to be the exponent. So that'd give me the natural log of 9 to the third. What would 9 to the third be? 729. So yeah, 729. Very good. All right, and then to expand this 2x is the exponent, so it's going to come out front. So I'd get 2x times log base 7 of 3. Then our change of base formula, if I had log base b of a, remember that's going to become, you can make that 2 base 10 logs. The base, whatever the base is, that's the one that goes on the bottom. It looks like that. So this would give me log over log, right? The base is 5, so it goes down here, and then this is 138. And this would become both log base 10s, 14 on the bottom, 2 on the top. Okay, any questions? So keep that handy because that's going to remind you of how to handle these. That's why I put it on a little piece of cardstock for you. And let's do some other expanding and condensing. Okay. So we're going to use the properties. This tells us to condense into a single logarithm. So we have subtraction, which means that I'm going to change that to division, but I can't do that until I take care of that 2. What happens with this 2? What can I do with that? Exponent. Very good. So I can bring that up there. So that would be log of 6 squared minus the log of 9. Right? So now I have 2 logs being subtracted. They have the same base. I can condense them into 1 log with division, and I'll go ahead and make 6 squared into 36. Put that over 9. What's 36 divided by 9? 4. So it reduces to log of 4. Easy enough? Okay. So then we have 4 log base 4 of A plus 2 log base 4 of B. So this 4 becomes an exponent up here. This 2 becomes an exponent up here. So that will give me log base 4 of A to the 4th plus log base 4 of B squared. Can I condense this some more? They're being added, so what do I do with the A and B thing? Multiply, so I get log base 4 of A to the 4th times B squared, and that's all you can do, and that's your answer. Okay, what questions you got? All right, you try number 3. So that's what I got. See if you agree. Make sure your exponent on the V is a 6, not a 5, because when I bring this 3 up here, it becomes a power to a power, and you multiply them. Okay, your power rules. We good with that? Yes? Awesome. All right, so then number 4, we have 3 things there, but we can only really do 2 at a time. So we're going to, we can combine those first. So they have the same base, so that'll give me log base 2. And then when I multiply them, what's 4 times 15? 60. And then I have minus log base 2 of 6. Right? So then that gives me log base 2 of 60 over 6, which leaves me with log base 2 of 10. We good? Okay. Let's look at number 5. So before I start combine, well, actually, I can go ahead and combine these two pieces and then take care of this up here as the exponent. All right. So this log base 3, and that'll be of 4 times y, plus, then this would be log base 3 of 49 to the 1/2 power. What's another way to say something to the 1/2 power? Square root. So this would be just the square root of 49. What's the square root of 49? 7. Okay, so you could have just put 7 there also. I just want to make sure you know where it's coming from on your notes. So then I'm adding 2 logs with the same base and it can multiply. So this ends up giving me log base 3. 4 times y times 7 is 28y. Okay. Any questions about where any of that came from? All right. Now let's look at number 6. I've got a couple of options here. So I could combine this stuff in here first and then worry about the 1/3. If I do that though, I'm going to have to do 8 times 27, which is not super horrible, but it'd be nice if I didn't have to multiply big numbers. So instead, we're going to go ahead and distribute this 1/3. This is going to give me 1/3 times log base 5 of 8 plus 1/3 times log base 5 of 27 minus log base 5 of 3. Okay. So now that 1/3 is going to become an exponent on each one of those. So log base 5, that 1/3 is actually the cube root of 8. Plus log base 5, that 1/3 is going to be the cube root of 27 minus log base 5 of 3. Okay, everybody with me on all that? Now, what's the cube root of 8? 2. So this becomes log base 5 of 2 plus, what's the cube root of 27? 3. So plus log base 5 of 3 minus log base 5 of 3. So not only did I not have to multiply big numbers up there, I'm not even going to have to multiply numbers down here because look, these two things right here zero out, and your answer is log base 5 of 2. Any questions at this point? Okay. All right. Why don't you do number 7? Y'all agree with that? But what is log base 2 of 2? 1. I can actually take that a little bit farther there. Everybody okay with that? All right, let's look at number 8. So this 2 is going to become an exponent up here. This 1/4 is going to become an exponent up here. This will give me the natural log of 6 squared minus the natural log. Now that 16 to the 1/4 power is the same thing as the 4th root of 16 plus the natural log of 3. Right, so natural log of 6 squared would be the natural log of 36 minus, so when you take the 4th root of something, it's easier than the 3rd root because you just take the square root and take the square root again. So the square root of 16 is 4 and the square root of 4 is 2. So this is the natural log of 2 plus the natural log of 3. So now I can start actually combining them. This is subtraction, so it would become the natural log of 36 divided by 2. What's that? 18 plus the natural log of 3. Then I'm going to have to multiply 3 times 18. What does that give me? 54. Okay. Any questions about condensing? All right, because now we're going to expand. So put them together, we're going to pull them apart. Okay, so I've got log base 6 of x times y times z to the 4th. Okay, so that 4th is only on z. If it was on the whole thing, I would handle this differently, but it's only on the z. So I can go ahead and split these 3 things up and make this into log base 6 of x plus log base 6 of y plus log base 6 of z to the 4th. You with me on why that's okay? Because that's my product property. Now, there's nothing else I can do with these first 2, but for this 4, it can come out front here. So this would become log base 6 of x plus log base 6 of y plus 4 times log base 6 of z. And that's the best we can do. Okay. Any questions? All right. Number 10. Now again, that 9, it's only on the A, it's not on the whole thing, or we would handle it differently. So basically I just have the log of 2 things that are being divided, so I can change that to subtraction. Get log base 4 of A to the 9th minus log base 4 of B. Can I do another step? Yep, got to pull that 9 out in front, right? So this becomes 9 times log base 4 of A minus log base 4 of B. Okay, everybody with me? Always top first, yes. Yes, absolutely. Good question. Anything else? All right, number 11. Now that we have exponents on the variables, but there's also an exponent on this whole thing. So it's log base 7 of this thing squared, which means we want to take this 2 and bring it out front. Oh, goodness. Bring that 2 out front, like so. Okay, so this is going to give me 2 log base 7 of q to the 4th r squared. Okay. So now we can split them up, but we have a 2 out here, so we got to have parentheses when we do this. So this is going to have to be 2 times, and then I can split them up, log base 7 of q to the 4th plus log base 7 of r squared. Do we understand why we needed parentheses there? Put a number out front. Now I need to bring my exponents down inside the parentheses. So this will give me 2 times, bring that 4 down, we'll get 4 log base 7 of q plus 2 log base 7 of r. And then my last step would be to distribute the 2. So in the end, I will end up with 8 times log base 7 of q plus 4 times log base 7 of r. Now, when you split it, if at this point you kind of skip this step and go ahead and bring the exponents down, I'm okay with that as long as you're not getting lost in your work, okay? Any questions at all? You have a question? Are you sure? Okay. All right, so then y'all try number 12. We agree? And I did skip that one step just so you can see it's okay, but some people do, and then some people prefer not to because they feel like they'll make stuff up, so whatever works for you, okay? Any questions at all? Good? All right. So let's look at number 13. All right, so I have the natural log of the natural log of the square root of 7x cubed. Okay, so we need to take our roots and make them into exponents. So this would be the natural log of 7x cubed. That square root becomes what as an exponent? 1/2. 1/2. Okay. Now we work it just like the others. I'm going to take the 1/2 out front. So 1/2 times the natural log of 7x cubed. Then I need to split these. So I'm going to have 1/2 with parentheses. Natural log of 7 plus, I'll go ahead and pull the 3 down, 3 times the natural log of x. So then I distribute, and I'm going to get 1/2 times the natural log of 7 plus 3/2 times the natural log of x. Okay. What questions you got? All right, so we look at 14. We have a 4th root. So what is that exponent going to become? 1/4. You got it. So you do number 14. When you're done, double check yourself with me. Make sure you reduced that 2/4 to 1/2. Any questions at all? You got this? You log experts? Awesome.